Hi everybody, it's Mrs. Dinkelman, and we're moved on to Unit 13 about polar equations. So just like parametric equations, we have to know how to do all those calculus things in polar equations as well. One thing that is a bit different is in parametric equations, we are not required to find the area under the curve. In polar equations, we will be asked to find area with that. So I know you've done polar equations probably before in pre-calc if you got to that. And I'm just going to kind of assume that you need a little bit of review or you need some basics to make sure that you know what you're doing. So these formulas that we want to commit to memory, normally, and this technically can change, normally we see something that's an r comma theta. When we look at a point, it's usually a little bit more obvious that we're which one's the angle and which one's the radius. Just always in radian in calculus, except for some of those applications like we saw in parametric. That will not happen on the AP exam. Just remember, always radian. So just kind of a quick overview of polar, I guess, really quick is instead of worrying about like what the horizontal and vertical component are, we're instead talking about how far out something might be from the pole or the origin and at what angle it might be. So I like to think a lot about radar when we're doing this one. So kind of that blip that goes around in the circle, that will help us when we get to area as well. So we want to know how far they are away from us if we were the pole and at what angle. Okay, so a quick reminder, and you kind of know this already, at least about the unit circle when r is 1. You know that the x-coordinate is cosine and the y-coordinate is sine. It's just that we're not always going to deal with r being 1 in this case. And then tangent, well, sine over cosine, so that's going to work y over x. This is just kind of a formula for a circle, x squared plus y squared equals r squared, and that will help us if we need to ever find the radius because we're in the xy coordinates. And then, like I said, a lot of times we call the origin the pole. Okay, so just plotting. So 4 pi over 2, I kind of like to think reverse. So find the pi over 4 first and then go 4 rings out from there. 1, 2, 3, 4. Okay, find another way to write that. Well, we could do something like, let's see, we could go backwards. So we could go 4 and then negative 3 pi over 2. We could also go 3 pi over 2, and we could have a negative radius. So if we have a negative radius, that shoots us this direction, and that kind of the opposite of the way. And then this also wants us to convert to Cartesian coordinates. So remember our x is r cosine theta. Let's try that again. So in this case, that's going to be 4 cosine pi over 2, and then y is r sine theta. So that's going to be 4 sine pi over 2. So cosine of pi over 2 is 0, sine of pi over 2 is 1, so we should have 0, 4. Now we should have also already known that, so here's the thing for some reason that completely blew my mind and took a really long time for me to make the connection, and maybe you aren't this way, but just in case you are, that if I graph it in polar or if I graph it in Cartesian, that it's the same picture. It's just a different way to describe the picture. So if I look here, 0, 4 makes sense because if I kind of superimpose the Cartesian coordinate system on top, that's where it would be. So anyhow, that's just something that was a struggle for me for a long time. It's not just graphing something different, it's just describing it in a different way. Okay, so example 2 here, trying to prove that these are the same. So there's lots of ways to convert back and forth, and maybe we'll kind of try both ways. So I'm going to start with this one and maybe just multiply both things by sine. And so then we get y equals 4. I'm trying to think of how I would do this one as y equals 4, just trying to use what I have up here. I guess we just kind of, nope, that's the same way. Anyhow, that's how I would find it. The other one is just reverse. We just replace this with r sine theta and then solve for r and we get the same thing. So just lots of ways to kind of convert back and forth to verify that things are the same. Okay, so that's what we're doing here. Plotting points, finding different sets, so converting from Cartesian to polar, Same thing here, Cartesian to polar form, okay? And then polar back to Cartesian or rectangular. Graphing on a calculator is really helpful. Just kind of a by the way, when I first start with polar, I graph a lot. So I spend a lot of time on the calculator just helping myself out. Just a quick reminder how to change the mode, and maybe we'll do one of these just because. So we'll want to go to polar. And something's in there already. So interesting. So that's is that a limestone with a hole or a little loop in the middle? So let's just do I don't know, let's just do r equals 3. So r equals 3 is just going to be a circle with radius 3. But something that's helpful for me, that by the way, that looks like an ellipse, and that's because we have a rectangular thing going on here. And I do a lot of tracing just to kind of make my brain make sense. And so part of the issue with this is it doesn't give us perfect values for theta. So it says 1.57, which is pi over 2, so that makes sense. And then hopefully this says something close to 3.14 and so on. This seems like a simple one. Let's just go look at r equals sine theta real quick. So sine, the theta is over here above the caret. Fortunately, that one's not just readily available. Okay, so here's sine, and I don't know, let's zoom in on that just a little bit. Let's just change the window maybe. So just kind of a reminder here, this is a lot like t. So this is saying go 0 to 2 pi, which just makes sense. And that's our t step, so depending on how slow or fast and what increments we want. It looked to me like maybe what would be helpful is, let's just cut this down a little bit. -5 to 5. And then, let's see, that was a little bit too big. So let me just tell you, I know what the graph of 10 looks like, and we'll look at 12, or we'll talk about 12 at the same time. Sine is a circle that's on the y-axis, and it's going to have radius 1, or diameter 1, excuse me. 12, when you graph that one, that's going to have diameter 2, but it'll still be on the y-axis, just like this one is. So you can see here, this one up to y equals 1. So this one is kind of interesting to trace because, just watch what happens here. So when I get up to there, pi over 2, okay, that makes sense. Then I get back down to here, and we're at pi. And basically, if I keep going, now I'm going around the circle again. So some graphs get created in that 0 to 2 pi window, but some, like this one, and if it was a cosine, same thing, it only takes me to pi to get one complete graph. So I have to be careful about that when I get to area for sure. Okay, a little bit of graphing. So what I want you to do is try to think of a table of values or plug in some values and see which ones of these make sense first before you get to your calculator. And then I think that's it.